Okay, the small pipe, I know the answer. Let x be the number of hours it takes the larger pipe to fill the pool. Then x plus 2 is the time it takes the small pipe. And putting this into a nice table, x hours for the large pipe, x plus 2 for the small pipe, 99/20 for both pipes together. The portion done by one pipe plus the portion done by the other pipe is the portion they do together. Therefore, this equation, multiply by the least common denominator, distribute, collect like terms, you get a quadratic. Factor out the 2, divide by 2, you have smaller numbers here. Use a quadratic formula, you're supposed to come out with 79 plus 1 or 1/20. Forget about the minus. And that is supposed to be 9 hours. So the large pipe takes 9 hours to fill the tank, and the small pipe 11 hours. Okay. Second example, a ball is thrown upward at 64 miles per hour. I have to be careful, there's probably a discrepancy right here. So I need to redo this problem. Okay, this part is correct, I think. So making the assumption that we work with this, we complete the square again, we get the following. And the maximum height is obtained when this drops out, so I subtract as little as possible. I subtract 0, that gives me 70. But 70 what? 70 feet? Okay, so the velocity is in feet per second. So that 64 should be, feet per second, okay, not miles per hour. So everything is in feet and in seconds. I have to go back and redo that. So I got a perfect square. It takes 2 seconds for us to reach that height, but the ball, the sheet, is at 75 feet, so the ball did not reach the sheet. Let's replace the 64 feet per second, not miles per hour, by v. Complete the square again. You subtract 16 first. So you get 16 times v over 16 right here. And you need this number squared. You subtract 16 times that number. You add that same number. You added 0. Minus 69. You subtracted 75 from 6. You complete the square. You want this to drop out. And you want this to be used to give you the velocity. So doing that, we come out with this quantity here, which is 75. And when I crank that out, I am supposed to get 96 feet per second. So you need a minimum of 96 feet per second, not miles per hour, to reach the sheet. And since we have done 2 exercises, let's do the third one also. Let x be the speed of the car, x plus 6 the speed of the motorcycle. Then the distance is 180 feet. The time is 180 over x, 180 over x plus 6. And one takes 5 hours more, or 1 hour more than the other one. One takes, where is it? The speed of the car is 6 miles per hour, and per hour more than, where is the time? I'm assuming that the time difference is 1, a motorcycle takes 1 hour longer, here it is, 1 hour longer, it is 1 hour. Right here. So this is the time of the car, this is the time of the motorcycle, this is whatever it is. One is I need to know what's what. The car is 180 over x plus 6, and the motorcycle takes 1 hour longer than the car, so this is correct. Multiply by the least common denominator, distribute, collect like terms, you get a quadratic. apply the quadratic formula, and you're supposed to get x, which is 30 miles per hour. Now this is a little bit fast. You can stop the tape anytime. You can look at the numbers and see if they agree with what you have done.